Hi, I'm Pat Kelly. Okay, got a little bit of work to do. Hopefully you're sitting down, but don't worry, we'll get through this. In this problem, they give us a data set, a set of ordered pairs, and they're asking us to come up with the least squares regression parabola. And we're also going to use a graphing utility at the end to verify. All right, now what it really comes down to then is using this system of equations. That's all this really is, and it's really your formula. This is going to be your driving force, so let this steer you. And I'm saying all that because even seeing what I need in this formula is what tells me how to set up this table. And this then guides me because I can see I need the summation of x's, and I need the summation of x squares and x cubes, even x to the fourth, x squared times y, and I also need x times y. So I say let that guide what you put into the table, because that's how I would have determined what to put in each column header. Then let's fill in the table, and your x's and y's come directly from the given data. That's why I've already put them in. For the rest of this then, just follow what you're supposed to do for each column. I mean, here's x squared, so take your x and square it. Square this one, 0, 1, and 4. Okay, let's flesh out the rest of this table. If I want to cube my x's, I'm taking this cubed, so minus 8. As always, be careful of your negatives. If I'm multiplying by another negative 2, that'll be a 16. I'm sorry, a little out of order. Maybe I should keep going down. Stay on track with the x cubes. So this is going to be a negative 1. That's still a 0. This cubed is 1. This cubed is 8. I got ahead of myself with this one. Now I'm raising each x to the fourth power. This to the fourth power I already did. This will be 1. This will be 0. This will be 1. And this will be 16. Next, x times y. So we're multiplying these two columns together. Negative 36 for that first one, multiplying these two. Negative 9, 0, 3, and then 12. Then my last column is x squared times y. So I'm multiplying these two columns, right? So 4 times 18, that's 72. Right, 40, 72. Multiply these, I get 9, 0, 3, and 24. Okay? Then the reason for this table in each of the columns is because I want to add them up, add each column up, and that's what I've got ready for myself here in that last row, is let's add up each column. So let's see, negative 2, negative 1, 0, 1, and 2. That's conveniently 0. That was actually whoever created this data set being nice to us, so good for that. Now I need to add up this last column. I do need to add up for my y's. So let's see, that's 10, 28, 37, 40. Right? Can always grab a calculator. Add these up. 4, 1 is 5, and double is 10. Okay. Add this column up. Check it out. They're actually kind of nice to us again. That's another 0, so that's good. Add this column up. Looks like two different 17s. 34. Adding this column up. Looks like 45 and 15 is 30. Can always grab a calculator for these. Negative 30. Adding this last column up. 96, 105, 108. All right, I'm only trying to do some arithmetic in my head when I think it's quicker than grabbing a calculator, but check those numbers. And then the point is with this table is we have different pieces of the puzzle to put in, not every place that I underline, but each of those sigmas, okay? So let's go to that now and put in all the specifics. N, I didn't mention yet at all, but N is always the number of data points. So we had 1, 2, 3, 4, 5. So for this N, that's just going to be a 5 times C, which is one of your unknowns. A, B, and C will be our unknowns in this system, and we'll solve for it. Next, my summation of x's, that's the first column, that's the 0. so it's actually nice, 0 times b, plus, I'm just looking at the formula, summation of the x squareds, that's the addition of this column, so that'll be the 10. So I get 10 times a equals, the right side of that first equation is sigma y, that's this column, that's a 40. And my next equation, sigma of x's, that's that 0 again, that's nice, 0 times c, plus sigma of x squareds, that's my 10 times b, plus sigma of the x cubes, that's this column, that's 0, that's again nice, 0 times a, equals, and the other side of that second equation should be the summation of x times y, that's my second to last column, negative 30. And my last equation from the formula, summation of x squareds, that's the 10, plus summation of x cubes was my 0, one of my zeros, plus summation of the x to the 4th, that's this column, that's a 34 times a, equals, and the right side of that equation has the summation of x squared y, that was my last column, that's your 108. Okay, you take a breath there, and you've got your system of linear equations set up. You just have to solve for a, b, and c, okay? Let's do that. And I'll grab the easy one first. That second equation simplifies, it collapses very quickly, because you got 0 plus 10b plus 0 equals negative 30. You're going to get an answer for b right away, okay? My b equals, divide by 10 over to the other side, and I get a negative 3. All right, we're a third of the way there. We have to get a and b and c. To do the a and c, I'm actually going to have to do a little bit of work. I'm going to take this first equation and double it. Let's multiply by 2. We've done systems of equations before. I'm motivated right now by getting these two coefficients to match. So if I double the 5, I get a 10 that matches this 10. 10c plus 0b, it's still a 0b if I double it, and this 10a becomes 20a. And I will double the other side of the equal sign as well and get an 80, right? We do that kind of work because now you can combine those two equations, this time by subtraction. I'll subtract these two equations so that my 10c's cross out. That's gone, that's gone. 34a subtract 20b, let me minus, just in case you look back at this, you want to realize you're subtracting that whole equation from the one right above. 34a take away 20a is 14a. And the other side of the equation is 108 subtracting 80, which is 28. See, it may not have looked like it at first, but they were actually pretty nice to us because they gave us numbers that are behaving, because that even divides nicely so that a is 2, right? You could get fractions, you could get decimals, there's nothing wrong with that. So they gave us some friendly calculations. Next, I'm going to take that a of 2 and plug it into either one of these equations, the first or the third. Something that has the a, not the b, would be nice. So I'll plug it in here. Let me switch colors again if it helps. Take that a of 2 and plug it in to this equation so that I will have 5c plus 0b, I'm not going to bother writing it. 2 in for a means plus 20 equals, you do still have the 40 on the other side. So if I slip this way just for a little bit more room, c will equal, oops, I didn't write the 0, that 40 on the other side. So, subtract over the 20, so I'll get 20 and then divide by 5, so I get c equals 4. Okay, and just to keep this together, that was my a value. So these are the three things I was looking for, a, b, and c. To put it all together, let me slip over here just for some space. The a and the b and the c are your coefficients of your parabola, your quadratic. So let's write our answer as y equals, grab your a value of 2, and that's the coefficient of x squared, plus your b value, I see it's negative, so I'll say subtract 3, that's your coefficient of the x, and then the c value, which was 4, that's just your constant at the end. So it's this equation that's our final answer. That's the equation of the parabola, that least squares regression parabola that they wanted. Whew. Good, but we also want to make sure that the graphing utility gets it correct, so they did want us to verify that. Grab your graphing utility. And depending what type of utility you have, you're going to need to get the data in, and for me, I'm using lists L1 and L2 for your x values in one of the lists, and your y values in the other list. Depending on your utility, you'll have a different way of entering the data. Get your x's in one data set, your y's in the other data set, and then I'm going to go to some kind of calculation of statistical models, depending on your utility. I'm going to stat and then calc. And you should have a quadratic regression option. So mine is quadratic regression. I hit enter. You do have to indicate where the data is. For me, it's in my first 2 lists. I'll hit enter, and what spits out as output for me is what A and B and C are. And my utility says A is 2 and B is -3 and C is 4. So we got it right. Okay, a lot of work, but I hope you find it rewarding. Go practice some on your own.